Hello and welcome. We are going to be continuing our exploring measures of variability with an introduction to standard deviation. So by the end of the lesson today, what I'm hoping for you is that you'll be able to interpret the standard deviation and then use that value to measure consistency. So this just continues on with our understanding of consistency. We did the mean absolute deviation yesterday, and today we're moving into the standard deviation. So when calculating the mean absolute deviation, we had to use absolute values to make sure that we got those positive values. So that way, when we went to go find the mean of it, we wouldn't end up back at zero again. So what's another thing in math that we could have done that would have given us a guaranteed positive answer no matter what number we put in? Well, you may have guessed it, right? But it's squaring each deviation, right? If we square any number, it always gives us a positive result. Okay, so a standard deviation, right? It measures the variability in a distribution using the squared deviations from the mean. So you may be asking yourself, well, why would I do that? What's the benefit of using that over the mean absolute deviation? Well, one of the biggest reasons why is because when we're looking with normal distributions, which we'll start dealing with in the next chapter, they're defined in terms of the standard deviation. So it's very important moving forward. Okay, there's also a lot of different techniques in statistics where you'll deal with the squared deviations, one of which is the least squares regression lines. We won't get to those in this course, unfortunately, but in a lot of statistics courses, you will get to that. So what does standard deviation measure? Okay, so standard deviation measures the typical distance between an athlete's actual performance and his or her ability. In other terms, okay, or in other words, okay, it's just the typical distance between the observations that we find and the mean of the data. Okay, to better understand this, we're just going to take a look at an example, okay, and talk about how it works. So here, okay, we have 82 simulated basketball games for 3 different players. Okay, so we have player 1, okay, his ability to score is 20 points per game, and he has a standard deviation of 5 points per game. The second player also averages 20 points per game, but has a standard deviation of 10. And our third and final player also averages 20 points a game, but has a standard deviation of only 2. So standard deviation, right, shows us how spread out our data is. So let's take a look at each individual one. Okay, so player number 1, right? He has this 20 points per game average, but look how incredibly spread out, right, due to random chance he has, right? So it's spread out quite a bit from 20, right? We have values all the way over here up at 34. We have values all the way down here, to 6 points per game. So they're pretty spread out. Okay, so that 5 means, right, on any average night, he scores 5 points away from that average. Okay, so the second player, okay, was simulated and has a standard deviation of 10. Well, holy cow, dude, 10 is super spread out, right? His values go all the way down here to 1 point and all the way up here where he's all the way to 45 points. So he's even more spread out than the first player. So on any given night, he averages scoring 10 points away from that mean of 20. And in our third and final one, okay, we have here, right, the standard deviation is only 2. So here, right, there on an average night, his average score is only 2 points away. So he's only 2 points away from his mean is how far he averages away. So as you can see, right, he's significantly, right, more consistent. His data points are grouped together in so much tighter fashion. Okay, so when we look at these 3 players, right, it's very clear which one is more consistent. Okay, down here with the standard deviation of 2, right? So that's player 3. Okay, as with the mean absolute deviation, right? The smaller the deviation is, the more consistent the performance is. And that looks, very true in the diagrams here, right? So in our dot plots, right, they're very closely grouped here. They're closer here, but a little more spread out, and they're significantly more spread out in the middle one. So that's it, guys. That's all we have here. It's just a really brief introduction to this idea. The smaller the standard deviation, the tighter knit, the more consistent the data is. And as we've been talking, right, a lot of the times, most managers, players, teams are looking for those more consistent players. They're not looking so much for the home run or strikeout guy. For those of you who are baseball fans, you may know of Adam Dunn, who is famous because he led the league in home runs and he set the single season record for the most strikeouts in history all at the same time. And I believe that season he also had the lowest batting average of a player with that many at-bats in baseball history. Just an example of a all or none hitter. So that is not what we are normally looking for, right? We're looking for those closer standard deviations. Okay, and so one last time, smaller standard deviation means that they are closer, right, and more consistent, your data points are. Okay, and remember, your standard deviation just tells you how far you are on average. Each point is on average from the mean. Hopefully you're having a wonderful day, and I hope you enjoy the rest of your week. Thank you very much.